Good morning, students. Today we'll be discussing laboratory program 6 based on circular queue and the operations of the circular queue under the data structure with C laboratory. So before going into the circular queue, let us see what is queue. So the basic definition of queue is a queue can be defined as an ordered list. A queue can be defined as an ordered list which enables insert operation to be performed at the one end called rear and delete operands to be performed at another end called front. Okay, so now how the queue operation works is, for example, this is a structure of an array. Okay, so this is in structure 0, 1, 2, 3, 4. So a queue can be defined as an ordered list which enables insert operation to be performed at one end called rear end. So here insert operation takes place over here. Okay, insert operation takes place over here. That is one end called rear. Insert operation one end called rear. It is rear, or also you can call it as NQ, and whatever. Also called it as insert. You can insert an element over here, and the deleting of an element is always done in this particular end. So that is front end, from the front end. So it can also call it as, you can delete from the front end, so we also call it as DQ. So that these are the three different names you can call. So delete or front or DQ, insert NQ or rear. So this is how the queue structure takes place. It can be defined as an ordered list which enables insertion operations to be performed at one end called rear and delete operations to be performed at another end called front. Initially, when we don't have anything in the queue, the front is equal to -1 and rear is also equal to -1 if they are empty. If it is empty. Okay, so here this is the definition. Now for example, I want to insert an element. So what are the what happens while I want to do the insertion into this particular queue? So when you want to add an queue, you should increment the rear end. When you want to insert, right, you should increment the rear first. Rear is equal to rear plus 1, and then queue of rear, you're going to insert that particular item, whatever the item is there. Okay, whatever the item is there. Now for example, let us try to insert A. Let us try to insert rear. Initially when my queue was empty, rear was -1, so it will be updated to now -1 plus 1, so it will be pointing to 0. Rear is 0. Now for queue of 0, I can put character A if I want to insert. So now your rear will be over here, so A will be inserted over here. Okay, A will be inserted over here. Next, if you want to insert again one more element, so rear will be again incremented, so rear will be pointing over here. Updated rear will be pointing. Let us insert B. So rear will increment, then for that queue of rear, I'm going to insert B. Similarly, I want to insert C, D and E. At the end, my memory is full, my rear will be pointing over here, and front is always over here, but our value of front is -1, right? Our value of front is always front. It looks from here itself, for value of front is -1. So if I want to delete an element from the queue, so we should increment the front. So front is equal to front plus 1, and that particular whatever the element is there, I'm going to delete from there. So queue of front is now, initially it was -1 plus 1, so it is pointing over here front. From this front, I'm going to delete that particular position. So queue of 0, A is there, I'm going to delete. So whatever is inserted first, right, that element will be deleted first. So that is how the structure. So front will be over here. Again, if you want to delete this particular this, so you will increment front, so front will be over here. Further, you go on incrementing the front if you want to delete C. So what is happening over here? There is one drawback in this particular structure. If you see here, here in 0, 1, 2, these elements are not there, and D and E. For example, if your max size of Q you defined was 5, okay, Q you defined was 5, and if you try to insert next element, rare should be incremented. So this memory will, if you increment the rare also, next I cannot insert, and this memory I cannot put because your friend is pointing over here. I cannot do anything with that. So here these memories is being wasted. So because of this drawback, we are using the concept of circular queue. So that's why the circular queue concept came. So that's why we're using the circular queue. In the circular queue, instead of all these blockage of memory, only one memory block will be wasted. Rest all will be reused in the form of circular. That is in the form of circular order. So that is why this is the definition of queue. A queue can be defined as an ordered list which enables insert operation to be performed at one end called rare. So rare where insertion operands and delete operations can be performed at another end called front. So always remember, delete is always from the front and insertion is always taking place with the rare. So Q is also referred to as first in first out. So you can see, first I inserted A, so I deleted the first element also A. For example, people waiting in line for a rail ticket form a queue. So the person who goes first to get a ticket will be the person who first goes out of getting the ticket. So that is regarding the definitions of the queue. The basic operations is same. NQ is to add into the queue, DQ is to delete from the queue. So I have shown already regarding the how to insert an element and how to delete an particular element. So this is regarding NQ, adding an element into the queue and removing an item from the queue. So these are the basic operations of the queue. This is the main problem with the linear queue. Although we have space in the array, we might have space over here, but we cannot insert any more elements into the queue. This is simply the memory wasted, and we need to overcome this problem. To overcome this particular problem, I am going to use the concept of circular queue. Now what is circular queue? Circular queue is nothing but it is a linear data structure in which operations are performed based on first in first out itself, and last position is connected back to the first position. It is also called a ring buffer. I missed to write, I wrote just buffer. It is also called a ring buffer. So it is a linear data structure in which operations are based on first in first out and last position is connected back to the first position. It is also called a ring buffer. So I'll just show you how the representation is done. In our program, we have defined the max size of array is 6. So let me draw the circular queue structure. This is the structure. So your queue of 0, queue of 1, queue of 2 and queue of 3, queue of 4. This is queue of 4 and this is queue of 5. Okay, queue of 5. So initially what will happen is you don't have anything over here. As I told, friend will be -1, rare also will be -1. Okay, so it is a linear data structure in which operations are performed like same how I have shown in the queue, but only thing is here it is in the circular form and last position is connected back to the first position. Okay, so how the representation takes place. Now for example, if I want to do the insert, right, if I want to do the insertion, I'll check whether your rare is equal to max minus 1. So for insertion, I need to check this. If rare is equal to max minus 1, what is my rare? Initially my friend and this rare is equal to rare is equal to -1. That -1 is equal to max minus 1, 5. It's not equal. Okay, if it is not equal, the condition, if it is equal, then it is an overflow condition. If this is condition satisfied, then it is overflow condition. So what I do is here initially in the concept of circular queue, if friend is equal to, one more is like if friend is equal to -1 and rare is equal to -1, I set friend is equal to 0 and rare is equal to 0. So if you see in the program, right, while explaining, directly I have written friend is equal to 0 and rare is equal to 0. So what will happen? Your friend and rare will be over here. Your friend will be over here and your rare will be over here. Friend and rare will be pointing over here. In case if friend is equal to -1 and rare is equal to -1, I'm going to set that particular condition. Okay, I'm going to set this particular condition. Once I set, I'll check for this. If rare is equal to max minus 1, your rare is now 0. I'll write this condition over here. If rare is equal to max minus 1. So what is there in max minus 1? What is there in max minus 1? Rare equal to max minus 1. So rare is 0, max minus 1 is 5. So it is not equal. If it is equal, right, my circular queue is full. Meaning is what? When rare is equal to, rare is what? When rare is getting pointed over here, 5. This is also 5 and max minus is also 5. When getting pointed over here, my circular queue is full. So that is what is the constraint. If it is not, I am going to increment the rare is equal to rare plus 1. So what was the rare value over here? It is initialized to 0, so rare will be 1. So at this position, rare will be pointing over here. Rare is equal to 1. For that queue of 1, I am going to insert the item. For example, let it be A. Similarly, if I want to insert, so that is how the insertion takes place. So again it will check if rare is equal to max minus 1. Now your rare is 1, max is 5. No, it is not equal, so rare will again get incremented. So rare will be 2. Now rare will be 2. At q of 2 I am inserting B. So here I am inserting B. Similarly, I'll insert C, I'll insert D, I'll insert E. Now when it comes over here, I can, my now rare is having value 5. Now it's satisfied. 5 is equal to max minus 1 is also 5. So when this condition comes, my circular queue is full. You might have noticed why this block is empty. So this is the only one memory wastage which is happening in this circular queue, but this takes place in the circular with only, but we can do the insertion in any order. Now for example, if you see, I try to this is regarding the insertion. Now your queue is full and you displayed all these contents. Now if you want to do the delete operations, what you're supposed to do is you'll check whether your friend is equal to minus 1 or friend is equal to 0. If friend is equal to both is equal to 0, that means rare and friend both are equal to equal. That means if your rare is also pointing here, you'll check if rare is equal to friend. That means if 0 initially it was 0, initially before that rare and this was 0, right? So if it was 0 equal to 0, then it would be your circular queue is underflow. If not, now your rare is over here and your friend is over here. If you just see here, our friend has not changed, only rare has been changed. So our friend is over here. So if you see here, only friend is there, friend is over here. So what I can do is, if that is, this is not, now rare is actually, what is the value of rare? You have 5 is equal to 0. No, it is not true case. So if it is so, your friend will be incremented to friend plus 1. Updated value of friend will be 1. So that queue of 1, whatever the content is there, that will be deleted. So this will be deleted. So initially friend will be pointing over here and this will be deleted. Similarly, again next counter also, friend will be incremented over here and this will be deleted. Again friend will be incremented and this will be deleted. Again friend will be deleted and this will be deleted. Again friend is over here, now this will be deleted. Now you check, friend and rare both are pointing to the same 5. Check what is the value of 5. So 5 is equal to 5. Both are pointing, but all the elements are deleted. When this condition comes over here, that means your circular queue is underflow. So these are the two operations which is again explained in the program. So this is regarding the definition of the circular queue. In circular queue, there is only one memory block wastage, but we are going to reuse the memory of whatever we had seen in the linear data structure. So this is regarding the definition of the circular queue. Next, we'll see the program explanation in the next slide. So lab program 6 is based on design, develop and implement a menu driven program in C for the following operations on circular queue of characters. So they mentioned circular queue of characters, and the implementation is based on array and with the maximum size as max. So the operations we have to do in this particular program is insert an element onto the circular queue, delete an element from the circular queue, demonstrate the overflow and underflow situation in the circular queue, as well as the display, as well as the exit. So this is regarding the lab program 6. So let us see the explanation over here. So the following are the header files and the declarations we are using. So hash includes standard io.h, as we are using for the printf and scanf. Max size is defined as 6. Initializing the circular queue with friend is equal to 0 and rear is equal to 0. Initially we initialize the circular queue with the front is equal to 0 and rear is equal to 0. And to insert the items we need to have a character. So character queue of max 6. That means max sizes of character we are going to insert is of the 6. So let us see the first function, that is first operation in the circular queue, that is regarding nothing but the how to insert an element onto the circular queue. So before we go to the function, so let us see what is the max, how the circular queue of max size 6 look. So let us draw this particular section. So max size is 6. So max size is 6. So we have defined q, right? So this will be nothing but, let us take this as q of 0, q of 1, q of 2, q of 3, and q of 4, and q of 5. So max is 6, so it will be from index is begins from 0 1 2 3 4 5, 0 1 2 3 4 5. So first in this, how we are going to insert an element. Initially we'll see with these items. We know that rear and front, that is nothing but we have defined over here, front is equal to 0 and rear is equal to 0. That means what? Front is pointing over here, rear is also pointing over here. Initially front is pointing over here, rear is also pointing over here. So why I require this char item is nothing but to read the characters, like whatever we are going to insert into the circular queue we need to read, right? So we are declaring char item. After that I'm going to check the insert function. So what insert function, as you know, first we are going to check whether a circular queue is full, circular queue is overflow, that means it is full. For that we are going to check if front is equal to rear plus 1 modulus max. When it reaches this particular status, our queue is full. So you check for the front value. What is there in the front value over here? We have 0 initially. First case we have 0. 0 is equal to what is the rear value also is 0. So 0 plus 1 modulus of 6. So you know that it is 1 modulus 6 is nothing but 1. So 0 equal to 1 is not possible. If that is not possible, it will come over here. So what will happen over here? Rear this is not there, so it will go to the else section. So rear will be nothing but rear plus 1 modulus max. So rear plus 1 is nothing but 0 plus 1 modulus 6. So it is 1 modulus 6, so that is nothing but 1 modulus 6, that is nothing but 1. So rear got updated to 1. Now we are going to once you got updated to 1, rear will be pointing over here, rear will be anymore over here because it got incremented. Rear is equal to rear plus 1 modulus 6, we got 1 itself, so rear is pointing over here. After that, enter the character to be inserted. Whatever the character I want to insert over here at this particular position, I need to read that particular character. So before I read that particular character, I've used the term f-flush standard in. So this is typically used for output stream itself. The main purpose is to clear or flush the output buffer and move the buffer data to the console. That is, in case if you have any previous data that is there in the buffer, it clears that particular data, and whatever the new data is being read, that will be stored. So in case any previous data is there, to flush that particular data in the buffer, I'm using the term f-flush standard in, and this is mainly used for the output console. Scanf %C and item. So what I'll be reading over here, I'll be reading a new item. So our item is A. So our item is A. Once I read that particular item, my queue of rear is what? Rear value is 1. In the queue of 1, A is being inserted. So what is there in queue of 1? A will be inserted. So this is when it takes place in the first iteration, when I want to insert a particular element. Now again, if I want to insert, let me try to insert A, B, C, D, E, all these elements. So again, when I want to insert, I'll check again for the next iteration. Front will be 0 itself. My updated rear is 1. So 1 plus 1 modulus 6 I'll check. 1 plus 1 modulus 6. So it is actually 2 modulus 6. 2 modulus 6 is 2 itself. 0 is equal to 2. It's not possible. So it will come over here. So your rear will be updated to rear plus 1. What is the value of rear now? It is 1. So it will be nothing but 1 plus 1 modulus of 6. So you know 2 modulus 6 is nothing but 2 itself. So your new rear will be updated over here. Okay. And once you updated the rear, enter the character to be inserted. Same again, you have to flush the before if anything is there in the buffer. I'm reading B, and that B, that is Q of 2, I'm inserting that particular B. So that will be over here. Q of 2, I'm going to insert that particular element, so that will be over here. That is regarding Q of 2. Next again, if I want to insert over here, like I want to insert C over here, so what I'll do is I'll come back over here. Again, I want to insert. So if front is equal to rear plus 1, we'll check for 0, 0 is equal to, your rear was previous, it was 2. So 2 plus 1 modulus 6. 2 plus 1 modulus 6 is 3. So your 0 is not equal to 3. So it will not go with this particular function. Instead, it will come to rear. Rear was 2. So it will come 2 plus 1 modulus 6. So it will be 3. So it will be 3. So your rear is updated over here. Now your rear is over here. That is 3. So in that 3, what I need to do, next element I need to read. So let me read C. So Q of 3, I am going to insert C. So here C will come. Similarly, the insertion goes on till here. Let me insert D over here. Let me insert E over here. So at this particular position, my rear is what? Now rear value will be updated to 5. At this particular position, my rear is pointing over here. Rear is over here. At this particular position, my rear is updated over here. Okay. So now when I check, my rear value is equal to 5, updated. Now I just showed 3 iterations. Similarly, if you give, rear value will be updated to 5. Rear value will be updated to 5. So when it goes rear value is equal to 5, now you check whether, now it your full queue is, circular queue is full, because one memory is left out free in the circular queue, rest all the memory blocks are being used. So here you will check if front is equal to rear plus 1. So what is the front value? 0. That is equal to 5 plus 1 modulus 6. So it will be nothing but 0 is equal to 6 modulus 6 is nothing but 0. So it is true. When such criteria matches, circular queue is full and it is overflow. So this is regarding the inserting an element onto the circular queue. So once we are done with the inserting, before going to the deletion of the element from the circular queue, let us see the status of the circular queue. So we already have these contents. So let us display the contents of the circular queue. So over here, so this is Q of 0, Q of 1, Q of 2, Q of 3, Q of 4, and this is Q of 5. Okay, so what was happening over here? Front was over here when we filled A was here, B was here, C was here, D was here, E was here. When we filled these things, rear was pointing over here. So finally, if you go back and see the insert function, finally rear was pointing over here. So come back over here. Now for this, I will show the display functions over here. So you know that if front and rear both are at the same position, front as well as rear, then your queue is actually empty. You don't have anything in the circular queue. If not, I need to display the contents of this. So initially I'll go front is 0 and your rear is actually 5. So both are not equal. So it will come over here, contents of the queue. So the first iteration is I is equal to front plus 1. What is the value of front? Initially it is 0. So front plus 1 is 0 plus 1 modulus 6. So it is nothing but 1 modulus 6 is 1 itself. So 1 modulus 6 is 1 itself will get, and I value 1 not equal to rear. Yes, it is true. 1 not is equal to rear. 1 is not equal to 5. If so, printf whatever is there in that particular queue of 1, what is there? So A will be printed. /t is for the tab, so A will be printed over there. Okay, so in this iteration A will be printed. Next I should be incremented, that is it will go back to this particular case. So it will be I is equal to I plus 1 modulus 6. So next iteration is I is equal to I plus 1 modulus 6. So it will be I is equal to I plus 1 modulus 6 is nothing but 2 modulus 6. So I value is updated to 2. So when I is equal to 2, sorry, I is equal to 1 plus 1, I is equal to 1 plus 1, that is I not equal to rear, I is equal to 1 plus 1, that is 2 modulus. So I will be equal to front plus 1. What is front plus 1 again? I is equal to, I is equal to 2. For that I is equal to 2, I need to see for this particular character what is there in the I is equal to 2. For I is equal to 2, initially this is satisfied, next iteration I will be this. So I is equal to 2, I need to check whether 2 is not equal to rear, 2 is not equal to 5. Yes, it is true. If it is not equal to 5, if it is not equal to 5, I need to display what is there in Q of 2. What is there in Q of 2? It is B. So that B will be displayed. Again, next iteration I will be here, I will be 2 plus 1, 2 plus 1 modulus max, 2 plus 1 modulus max, 2 plus 1 modulus max. Modulus max is nothing but 2 plus modulus max is nothing but 5. Modulus max is nothing but 3. So now your updated value of I is 3. So then you'll check whether 3 is not equal to rear. 3 is not equal to rear is what? 5. Yes, it is true. So again you will print Q of 3. What is there in Q of 3 is C. So that will be printed C. Similarly, I will be next I will be like updated to 3 plus 1 modulus max. So that is nothing but I value will be updated to 4. 4 is not equal to 5. It is true. Whatever is there in Q of 4 is D will be printed. D will be printed. So for initially this will be taken. Next onwards this itself will be updated value of the I. Next what we'll do is I value is incremented and it will be 4 plus 1 modulus max. Modulus max is 6. So it is I value is updated to 5. So we'll check 5 not equal to 5. This is false. So this statement is done. It will actually this is supposed to be within this. So this statement it doesn't work. It will come to and work with this particular statement. So what is there in that particular statement is Q of I, that is Q of 5. So E will be printed. So this is regarding the display status of the particular function. So initially from where we had to start from here. So we are declared front plus 1, that is 0 plus 1 modulus max, and then 1 not equal to rear. From there we started, and then with this particular I value I started printing that particular statement. So this is regarding the display status of the circular queue. Next, let us go to the deletion and element from the circular queue. Next, let us go to the deletion of an element from the circular queue. So we had seen in our circular queue we had Q of 0, Q of 1, Q of 2, Q of 3, Q of 4 and Q of 5. So the front was pointing over here and rear was over here. Okay, and the elements were A, B, C, D, E. Okay, if both front and rear are pointing in the deletion function, you know, if both front and rear are pointing at the same, if both are in the same location, then the circular queue is underflow. That means your circular queue does not have any elements over there. If not, now initially where is your front position? Front is in the 0, rear is equal to, rear is in the 5th position. So initially we have 0 is equal to 5. This is not equal. If not, it will come over here. Front will be updated to front plus 1, that is 1 modulus 6. So it is 1. Okay, 1, and delete the character. Whatever the character is there from the Q of 1, I need to delete. So whatever is there in this A, that will be deleted. That will be deleted. So Q of A is done. This has been deleted. Now this is empty. I don't have any element over here. So I can just take the eraser and delete that particular A. It's done. Next, Q of front, whatever is there, that will be deleted. So Q of 1A was there, so that got deleted. After that, again if I want to check, again if I want to do the delete option, now front is updated to 1. Your front is over here, front is over here, front is updated to 1. So when you want to delete that particular option over there, that particular front is over here. Now if you want to delete B, again you will check front 1 is equal to 5. Your front is 1 now, it's not equal, so it will come over here. So in the next iteration F will be nothing but 1 plus 1 modulus 6. So that is nothing but 2. So whatever is there in Q of 2 will be deleted. Q of 2 is B, so that will be popped. Similarly, Same thing it happens to C. So again, if you want to delete C, you'll check for whether 2 is equal to 5. It is not equal to 5. It will come over here. Front will be nothing but 2 plus 1 modulus 6, so it will be nothing but 3. So whatever is there in Q of 3 is C, so that will be deleted. So that will be deleted. So C is also deleted. So when it comes over here, for the last position, front will be equal to 5 and Q of 5, front is equal to 5 and the Q of 5 will be E. This particular element will be deleted. Now all the elements over here is deleted. So this is deleted. Now when you see over here, finally front will be updated over here. When it comes over here, front is updated over here. Now you check front and front is having the value 5 and rear is also having the value 5. Both are equal. When this both condition matches, the circular queue is underflow. So this is regarding the deleting an element from the circular queue. So I hope it's clear with the insertion an element into the circular queue, deleting an element from the circular queue, as well as regarding the display status of the circular queue, and then regarding the main function. So main function is similar. We have void main, in choice and infinite loop. Whatever the operations you're going to do that are printed over here, circular queue operation, enter the choice. So insert, delete and display, and whatever the percentage D, whatever the choice you want. For example, you give 1, switch 1, it will go to the insert function. Then if you want choice to delete and display, and if you want to exit from that, then return, and in case if you press any other, it is an invalid choice. So this is regarding the main function. So let us see the execution of the circular queue in the code block. Now let us see the execution of the circular queue program in the code blocks. So we are same thing, hash include max size is 7 and front and rear is initialized to 0, and insert function, what I explained over there, and then delete function and display, and finally we have the main function. So let us see how the operation of circular queue works. So let us run this particular program. Okay, so we have the choices of insert, delete, display. A max size of the circular queue we are defined as 6, but the maximum element I can insert is 5 because one space is left blank in the circular queue. As I told, only one memory block will be left out free over there. So I'll try to insert one character A. I inserted A. Again I'll try to insert, sorry, I deleted the character A. I'll try to insert again. So I insert the character A, again 1, I'll insert the character B, again 1, I'll try to insert the character C, again 1, I'll try to insert the character D, and again 1, I can insert the character E. So totally 5 characters I have inserted, but you know only 5 characters can be inserted and one memory block is left free over there. Again if I try to insert, it will give circular queue overflow. You can see here circular queue overflow. Try to display the contents once you insert, and once you show the circular queue overflow, try to display the contents. So you can see we have A, B, C, D, E over here. Now you try to delete the contents, so it is first in first out, so you give the delete. When you give delete, deleted character is A. You can try to see the display. A is not there, B, C, D, E is there. So try to delete all the elements. I deleted B, again C, again D, again E, and then try to again delete. Nothing is there. It shows that circular queue is underflow. And now try to display. You come to know that circular queue is empty. So while showing the output, you need to show the underflow condition, you need to show the overflow, you need to show the empty, and also you need to show the display of all the elements of the circular queue. So this is regarding the execution of circular queue program. Thank you.